So in this class, we will discuss a problem of analyzing a truss using method of joints. So this is a UTF question paper problem, February 2022. So this is the given truss. Of course, if you see the truss, the configuration, it is simply supported truss. There is a roller support here, there is a hinge support here. Of course, the loads are acting like this, and since if you observe that the loads are only vertical loads, that means horizontal loads, but since the supports are given vertically, reactions will be horizontal. So there is no horizontal reaction here because 8.4 kN, 8.4 kN, these are the forces acting at joints given, and these two are the support reactions RB and RD. Initially, we will assume the support reactions in the opposite directions of the forces given. So I will take RB like this and RD like this. Even though hinge support, there will be two reactions. In this case, horizontal reaction will not be there. So in this case, now these are the dimensions given in the problem. The first step in such a type of truss, that is in analyzing a simply supported truss, is to find the reactions. So there are two reactions here, RB and RD. We will find those reactions using equations of equilibrium. The first equation being sigma mv is equal to 0. I will take the algebraic sum of moments of all the forces including reactions about the point B and equate it to 0. The sign convention is clockwise moments positive. Now, if I take the moment at B, now this 8.4 kN will have an anti-clockwise moment about B. So 8.4 into 4.5 anti-clockwise, therefore it is minus. Then this RD reaction also gives an anti-clockwise moment. So RD into 4.5 is equal to 0. So both are minus. So if you simplify this, you get RD as minus 8.4 kN. This minus sign represents that the assumed direction is wrong. So it acts in the opposite direction. That means I have assumed like this, RD I have assumed like this, but since I have got negative answer, RD will act towards left. That is the meaning. Then to find the other reaction, you know that this RB will be equal to this total load, whatever is acting, minus RD. But that means the sum of reaction should be equal to sum of external forces. So if you use that, so 8.4 plus 8.4 minus RD. So minus RD is, once again RD is negative here. If you substitute here and simplify, you get 25.2 kilonewton. So 25.2 kilonewton is positive, therefore the assumed direction of RB is correct. So it is acting like this. RD is acting like this, whereas RB is acting like this. So this is the first step in the analysis of a simply supported truss. After finding the reactions, now the question here is we have to find the forces in all the members of the truss. So here, if you observe the truss, there are 5 members here: DB, DC, BC, BA, and AC. So we have to find out the forces in all those 5 members by using method of joints. Now first, we have to choose a joint in which there are not more than 2 unknown forces. That is very important because we have only 2 equilibrium equations to solve in method of joints, that is sigma fx0 and sigma fy0. So we have to choose a joint. Initially we have to choose a joint which has got only 2 unknown forces. Now for that purpose, I will take joint D here. If I take joint D, this reaction force is there, BD member is there, DC member is meeting. So we know we have to find the forces in these 2 members, DC and DB. So I have taken the joint D here and I have written the free body diagram of joint D. At joint D you have a reaction like this, 8.4 kilonewton, and there are 2 members meeting at joint D, BD and DC. So this is BD, this is DC. So if you calculate this angle is tan inverse of 4.5 divided by 2.8, it comes out to be 58.1 degree. Now here this, what we have to do is very important step is, initially we will not be knowing what type of force is acting in a particular member. So force can be either tensile or compressive in a truss. So therefore, initially we will assume that all the unknown forces are tensile forces. After applying the equilibrium equations and after solving for the unknown forces, if you get positive value, it is tension force only. If you get negative value in that particular member, negative value of the force, then it is compression. So that is the way we have to decide. Now here, when you want to apply the equilibrium equation, before that I have to assume tension force in the unknown members. Now here, away from the joint is tension, towards the joint is compression. That is the sign convention we are going to use for tension force and compression force. Now FDB I have to find out now, and FDC I have to find out. Therefore, FDB away from D, FBD will be there. This is tension. Away from D, FDC will be there. So this is tension. So FDC and FBD, they are tension forces which are taken away from D. They are the unknown forces. Now to apply the equilibrium equations, we have to resolve the inclined forces. Here FDC is inclined. If you resolve this force, it will be FDC cos 58.1 degree and FDC sin 58.1 degree, like this. Now we will apply the equilibrium equation for this particular joint. There are three forces here, 8.4, FBD and FDC. Of course, FDC is resolved like this, the two components. Now sigma fx 0, if you apply towards right positive and left negative, so if you see here, FDC cos 58.1 degree is acting towards it, that is positive, 8.4 is acting negative, so minus it is acting towards left, therefore negative minus 8.4 is equal to 0. So only two forces are there in the x direction. If you solve this, you will get FDC as 15.9 positive kilonewton force. So since it is positive, it is a tension force. So the force in the member DC is tension force and its magnitude is 15.9. Now, second equilibrium equation, sigma Fy 0. Sigma Fy 0 sign convention is upward positive, downward negative. So for the same figure, upward forces are FBD. So this is upward. Then this resolved component of this FDC will be FDC sin 58.1. So it will be FBD plus FDC sin 58.1 degree is equal to 0. So from this, we can calculate FBD. Already know FDC value 15.9. If you substitute that FDC value here, you get FBD as minus 13.5 kilonewton. Since it is negative, so it is compression. So the force in the member BD is compression, whereas the force in the member DC is tension. So positive value represents tension force, negative value represents compression force, because initially we have assumed that it is tension. If you get negative, it will be compression. Now, by taking joint D, we got the forces in two members now. Next we go to joint B now. If you go to joint B, there are three members meeting at B, BA, BC and BD. Along with that, at joint B, we have a reaction RB, which is equal to 25.2 kilonewton. Now, among these three members, we already have calculated the value of force in BD. Already you know that BD and DB, they are same. So already you know this. So only two unknowns will be there now. Force in this member BA and force in this member BC. Now let us write the free body diagram of joint B now. So joint B, you have a reaction of RB which is equal to 25.2 acting towards right like this. That we have to write down. Then this FBD force is 13.5. Please note that 13.5 kilonewton is compression nature. Compression in nature means at the joint B, that force should act towards the joint. So if it is tension, you have to take away from the joint. If it is compression, you have to take towards the joint. So since you have got compression, minus 13.5 will act towards the joint B. Now these two are unknown forces. One is FAB, another is FBC. So these two forces we have to find out now using the two equations of equilibrium. Now here also FAB is inclined force, resolve them horizontally and vertically. So these two are the components now. Now for this diagram, let us apply the equilibrium equations. Sigma fx 0 towards right positive. Now the equation will be FBC, this is acting towards right. We are assuming away from the joint. Please note that FAB and FBC will not be knowing. We have to assume that they are acting away from the joint, that is tension. If you get negative value, it will be compression. So FBC towards right is positive, plus 25.2 is also positive, and component of this will be FAB cos 58.1 degree, that is also positive. So all the three are positive here because they are acting towards right. Now from this, this is one equation we can solve because there are two unknowns, FAB and FBC. Now apply the second equilibrium equation, sigma Fy is equal to 0, for which I may take upward forces positive. If I take that, so here this 13.5 is acting upwards now. It is compression force towards the joint and sign convention is upwards, therefore 13.5 is positive, and along with that we have to take this one, FAB sin 58.1 degree, that is also positive because it's acting upwards, is equal to 0. Only two forces are there. So at this joint B we have to take the reaction and these forces. Now if you simplify this, you get FAB as minus 15.9 kilonewton, minus indicates that it is compression force. We have assumed tension but we got negative value, therefore it is the force in the member AB is compression force. Now since you know the value of FAB, that FAB value is substitute in equation 1. In this equation, substituting in 1, you will get the value of FBC. So FBC is minus 25.2 minus FAB cos 58.1 degree. That minus into minus becomes plus. So if you simplify that, you will get FBC as minus 16.8 kilonewton. It is also compression because it is negative. So forces in these two members are found out. AB and BC are found out by taking the joint B. Now totally we got forces in 4 members. By taking joint B equilibrium, we got force in member DC and BD. By taking joint equilibrium of B, we got the value of force in member AB and BC. So totally we got 4 forces now in 4 members. So last member which is left out is AC. So to find out AC, either you can take joint C or you can take joint A. I have taken joint A here because there are only 2 members meeting at joint A. So I have taken the equilibrium, that is free body diagram of joint A. At joint A, he has given a force of 8.4 kilonewton. That also we have to take. Okay, and there are 2 members meeting at joint A, AB and AC. In the out of which you know the force in the member AB. You have got AB, force in member AB as minus 15.9. Since it is minus, it is compressive force. So compressive force how to show? Towards A. We have to take that force as acting towards A. So 15.9 kilonewton is acting towards A. And from the geometry, you know that this angle will be 58.1 degree. And the unknown force is FAC, which we have to find out. Assume that as tension force. So tension force means away from A. Since you are considering joint A, we have to take away from A as tension force. So FAC I am going to take away from A like this. Now here also we have to resolve this force because it is inclined. If we resolve this force, resolution will be vertical will be like this, horizontal will be like this. So horizontal is 15.9 cos 58.1 degree, vertical is 15.9 sin 58.1 degree. Now here, since only one unknown force is there, only we have to find the force in the member AC. It is better you use only one equilibrium equation which consists of FAC. Since FAC is a vertical force here, so we have to take sigma Fy is equal to 0 equation. You need not use sigma Fx is equal to 0 equation. Go for sigma Fy 0 and upward positive. Therefore, the equation becomes this is upward 15.9 sin 58.1 degree plus FAC is acting downwards, so minus FAC is equal to 0. Therefore, if you simplify that, you get FAC as 13.5 kilonewton positive. That means it is tension force. So we got the answer for all the forces in all the 5 members. Now you can tabulate the result. So they will ask you to tabulate. You write like this: member, force in kilonewton, nature. Nature means either it is tension or compression. So T for tension, C for compression. Now whatever you have found out here, all the forces, we just tabulate them. So DC, you have got 15.9 tension force. Then force in member BD minus 13.5. That means 13.5 magnitude I have written. Compression is the nature. Then AB minus 15.9. So 15.9 compression. So BC is minus 16.8. So 16.8 compression. Then lastly AC 13.5 positive. It is tension. So these are the internal forces that have been developed in all the members of the truss due to the applied forces. So this 8.4 and 8.4, they are the external forces, applied forces. Due to that, they develops internal forces in the members of the truss. So they will be either tension in nature or compression in nature. So this is how we have to do the problem. In the case of a simply supported truss like this, first step is to find the reactions. Very, very important. Whereas in the case of a cantilever truss, you need not find the reactions. You can start from the free end. So that is the these are the steps which we are going to follow in method of joints for a simply supported truss.